Hello everyone, I am Athar Chauhan, and as part of presentation, I'll be explaining our age and productivity analysis using Z-score normalization, covariance, and Pearson correlation. We are working with real data from 18 students, and our aim is to understand how age relates to productivity. Just a second. Yeah. Our dataset contains 18 students with ages ranging from 23 to 61 years old. The mean age is 43.11 with a standard deviation of 13.03. Similarly, productivity score ranges between 7.8% and 42.5% with a mean of 28.72% and standard deviation of 9.18. These values will help us compute Z scores, covariance, and correlation. Now let's understand Z-score normalization. Z-score normalization helps us convert different types of data like age and productivity into a common scale. The formula is Z equals to x minus mu whole upon sigma. A positive Z-score means the value is above the average. A negative Z-score means it's below average, and values beyond plus and minus 2 are usually considered outliers. Now, Z scores for age. When we look at Z scores for age, we notice a clear pattern. Younger students, age lying between 23 to 27, have Z score around minus 1.2 to minus 1.5, meaning they are much younger than the average. Students in their late 40s and early 50s have Z score around zero point 0.3 to zero point 0.8, slightly above average. Older students, ages 56 to 61, have Z scores above 1, indicating they are well above the average age. This helps us visually understand the age distribution in the dataset. Now, Z scores for productivity. Productivity scores show an interesting spread. A few students are far below the average, Z equals to minus 2.28 and minus 2.10. Many students fall slightly below or slightly above the mean. Higher productivity values such as 41.2% and 42.5% have Z scores above 1.3, meaning they are well above average. So productivity varies more than age, and Z scores help us clearly identify who is performing at which level. Covariance. Covariance tells us how two variables change together. The formula is covariance x comma y equals to summation x minus mu x whole multiplied by y minus mu y whole divided by n. Our data set covariance is 115.94, which is a positive value. This means when age increases, productivity tends to increase as well. However, covariance alone doesn't tell us how strong the relationship is. For that, we use correlation. Using the formula for Pearson correlation where R equals to 0.97, R equals to covariance whole upon sigma x multiplied by sigma y. We get a Pearson correlation coefficient of 0.97. A correlation of 0.97 is extremely strong, almost perfect. It tells us that age and productivity move together in a very consistent linear pattern. In simple words, older students tend to have higher productivity scores. Now, what this relationship means? Our results reveal clear trends. Younger students, lying from 23 to 27 age group, have noticeably lower productivity. Mid-age students, around 39 to 52, show steady improvement. And older students, around 54 to 61, consistently achieve the higher productivity levels. This may be due to greater maturity, better time management, stronger focus, or clear goals that often come with age. Now, looking at the key insights and summary. To summarize our findings, Z-score normalization helped us standardize the data and identify how each student compares to the group. Covariance, which is 115.94 from our calculation, showed a positive rising pattern, and correlation from our calculation 0.97 confirmed a very strong positive relationship between age and productivity. Overall, data strongly suggests that productivity increases with age. Now, the conclusion and takeaways. In conclusion, Z scores gave us a clear picture of age and productivity distribution. Correlation and covariance showed that age is an excellent predictor of productivity. These insights can help educators design support system tailored to different age groups. Thank you for listening. I hope you enjoyed my video. Thanks for watching.